Good afternoon. My name is jain. My partner is Himanshu Sharma, and here we are with our final review of J review of data analytics. Our topic is predicting sales revenue. We use the advertising data. So here we start.
So the linear regression advertising dataset. So first we are going to read the dataset, which is advertising.csv, and these advertising datasets are particular product advertising budgets, TV radio, newspaper, and media like TV, newspaper, radio, media. So first we are going to see the first six elements of the advertising dataset, and then uh, then here is a summary for the dataset, and then like we are going to see the pairs plot for the all three medias, radio, newspaper, and the sales. As you can see the relationship between all the three medias. Now the like what is the advertising sales and the budget, like how they are related to the TV, radio, and the newspaper. So we are going to make a linear model between the sales and all the three medias, and data is the advertising data set, as you all know. So like here is the summary for our linear model. So they are the test hypothesis. So we are calculating the beta TV, beta radio, and the beta newspaper, and it comes out to be 0. So the f test, the f the from the f test, the p value is 2.277 into 10 to the power minus 6, which shows that the model is highly significant. So now we have to find how strong is the relationship. So to measure the strength of the relationship, we are going to find out the RAC and R square RAC. So like this is the like summary of linear model dollar sigma. So this is the RAC value, and now we're going to find the mean of the sales. Then this is 15.1305, and then we're going to find the R square from RSC divided by mean. So here we get the RSQ value. So like the predictor explains 90% of the variance in the sales. So like this is a correlation between the fitted value and the y like advertising sales between the sales column of the advertising data set. So it comes out to be 0.1235. So these are like which media contribute to the sales, because there are three medias. We are most to have to find out like which media mostly contribute to the sales. So for that we're going to find out the coefficients of our linear model, which comes out to be like this. The intercept, the standard, and the t value, and from the t value we are calculating the p values for all the three medias. Now the from the p values of the all the three medias in the above coefficients, we come to find out that the p values for the TV and the radio are low, which means the TV and radio are highly significant, but the newspaper is not come out to be the highly significant. So like newspaper is not contributing to the to our linear model, so we are going to remove it. So like we are going to say also set the limits, like this is the coefficient limits we are going to set, and lower limit and the upper limit. That means these are the confidence intervals for the TV and the radio. And now from the confidence interval we come to know that confidence intervals for the TV and the radio are narrow and far from the zero, providing evidence that these media are related to the sales. But newspaper includes zero, which means newspaper is not highly significant and is not like responding to the sales revenue. So this is the VIF value. The means like if newspaper is not contributing, what would be the reason? One of the reason may be collinearity. So we're going to check the collinearity in the variables. So we are going to use the VIF. If VIF is greater than 5 or 10, it indicates that there is a problematic collinearity. So like as you can see for the radio and the newspaper, it's very much less than 5. So this means there is no significance of the collinearity between the variables. Now we're going to predict the values of the sales by giving some random values to the TV, radio, and the newspaper, and it comes out to be like this: the lower and the upper value, as you can see. And now same, and then again we can give some random values. And interval this time is prediction, and above the interval is confidence. So this is the plot. As you can see, the three plot between the residuals, fitted, normal, QQ, and these are the scale locations. As you can see, these are the residuals, the remains, and as you can see, now there's a synergy which Churchill will explain.
The relation between two estimates. So here we can see that the sales is used as a square value in the strategy of advertising, and and which is just a summary. Moving down is the advertising. As we can see that advertising in data set is not additive. So we go for a testing. We do the summary in which we see the RSQ value, which is 0.1235, which means it's not additive, including the interaction terms in the model resulting in a subsequent increase in R square from 90% to almost 97%. So now we take a non-linearity of the transformation while using radius as the square value. So here we go with our third linear prediction model, which is LM3, where we use the radius square, and here we can see the summary. We can see the p value is very less. Moving on, we use ANOVA. ANOVA is used to perform the modeling, the plot of the model between the two models. So we'll analyze two models at a time, which is first model and third model, which is the nonlinear model and the linear regression model. We can see that the RSS square value is 1, which means our model is moving on, we'll plot the residual versus the fit model, and now we'll find the polynomial function using radio Q value. So this is a non-linear model. It is a third linear prediction model. So now we'll this is the summary of the model, and we can see that p value is greater than before, then the model is more stable. So finding then using ANOVA, we'll find the relation between the linear and the polynomial model, and we can see that the R square value is 1, which means our model is fit. Now plotting the residual and fitted model, you can see that there are so many plots, and uh, and this and now moving on to the testing is a system model where you so moving on to our fifth model where we use newspaper as a fair value, and we take our two polynomial models at a time, and then finding a relation between the fourth and the fifth model will see the ANOVA again, and which is the relation between the fourth and the fifth model. Then we'll perform chain regression to find out the chain nearest neighbor, and then we will plot our chain in regression model, which is into graphs. So we then find the value of our VR variance value is a 0.667. This formula may not work for multiplication or other models. Now we find the RSQ value, which is 0.825, and correlation of RSQ value is 0.83. Now we find if the model is comparable to the linear model. So we find the RSQ value, and the RSQ value can be find out is hold on. So RSQ value is 0.25, which means our model is not fitted well. Then we find the dimension of advertising data set, which we need to apply this to the data test data, not train data. Now finding a training test. Now finding a training and just dividing it into 80-20%. We will find the p value.
So these are our, this is our project. So thank you so much.